Hi everyone, and welcome to my talk on the commoditization of data engineering. So as with virtual today, I thought I'd kick off with just a brief introduction. So hi everyone, I'm Tom Taylor, and I currently head up the alpha development team here at Numeric. I've actually worked for Man Group for just over 10 years now. And primarily through my tenure here, I've been focusing on building research and data and trading platforms that underpin a lot of our systematic investment processes. I've been with sort of Man Numeric for the past 5 years, currently based here in Boston, Massachusetts. We're a quantitative equity and credit business. And so as you can imagine, data is really, really key to what we do day in, day out. So my talk today is on the commoditization of data engineering. And what do I mean by that? Well, what I mean is the general trend that lower level building blocks in the data science stack are now commoditized. We're seeing that data engineering teams is really shifting their focus from sort of low level database and storage administration. And instead, they're focusing much more on the higher value add part of the data value chain. And then finally, the data engineering and data science fluencies really growing across the organization. And it's growing in places that has perhaps historically been less technical. So the agenda for my talk today, I'll kick off with a look at why data is so important to the modern day investment process. I'll then look at the key themes that are driving the commoditization of data engineering. From there, I'll talk about how you can leverage open source within your own organization. And then finally, I'll share my thoughts on the future of data engineering. So why is data so important to the investment lifecycle? Well, I think what we've really seen and what we've witnessed since the internet age is a digital revolution in the economy. There's now just far more data out there at our fingertips. How have we been able to take advantage of that within the asset management industry? Well, we've coined the term alternative data, although I would argue that today, alternative data is just data, like any other data source that we have. And there's really been a huge explosion in the data landscape. So there's now thousands and thousands of data sets that as an asset manager, we're able to ingest and process and give us a really high fidelity view of the world around us. How might we use some of those newer data sets in our investment process? Well, if we look at something like revenues, with more traditional data sets, we could look at things such as their quarterly or annual reports. We could possibly bring in-house sell-side analyst estimates. So having an analyst kind of manually go through the company fundamentals, model the company, and provide us with an estimate of where they see revenue going. But in the alternative data landscape, actually we can get a much more fine-grained view. We can not only understand the revenue today, but we can also understand what's actually driving that revenue. Is it volume? Is it price changes? And we can also get a much more timely view. So a lot of the alternative data sources are daily and they're forward-looking. So they allow us to estimate at a much finer grain and a more timely manner than traditional data sets ever could. The sort of data sets that we might look at, so things such as credit card transactions, are we seeing consumers spending more at that organization? We can also look at brand sentiment. If the company was previously quite niche and they had quite a niche product, and now actually that's really growing in popularity and is taking off. Again, that's something that we could look at and we could see the trend, and that could enable us to predict that revenue would increase in the future. And then finally, if it's a direct to customer organization, we're able to look at their pricing, and we can understand if the reason that they're selling more is due to discounts that they're giving. So I think it's really key within the asset management industry to have the capability to ingest these new data sets. And I think what we've really seen is that if you have a really industrial scale data onboarding and data science capability in your organization. It's a real key enabler for alpha generation. So what are the key themes driving the commoditization of data engineering? I think there's three main ones. The first one's demand. And just like with the asset management industry, we're seeing more and more organizations see data as really their competitive edge. If you look at a company like Tesla, they have more data than any other car company on cars, and then clearly that's an advantage for them. The second theme is skills. So if you are able to get data into the hands of users who are really close to the domain that they're going to apply it to, I think that's generally where you see a lot of the value being derived. If it can help them fill in the mosaic of their understanding of the world, they're best placed to actually analyze and interrogate the data and derive that value. Because of that, I think we're seeing a general trend that users and organizations are skilling up with data fluency. And so less technical users are now much more comfortable at analyzing data and gaining insights. The final theme is technology. And we've seen really a huge growth in the open source ecosystem, and particularly in those core data engineering and data science packages. So that means that data engineering teams are less focused on the kind of very low level infrastructure of running and maintaining storage systems and databases. And instead, they're able to really focus higher up in the value chain, much more on enabling users to perform their own data analysis and enabling big data skills within the organization. So I mentioned open source in my previous slide. I thought I'd give you a sort of stylized example of what a modern day data science platform might look like. I call it a stack because it's generally layered, and at the bottom layers you see packages which are operating very much at the hardware level. And as you go up the stack, you get to packages which are much more tailored to the organization. So it starts low and then it goes up to high. What we've witnessed is a lot of commoditization happening in those lower and middle tiers, and I'll walk you through a couple of those packages in a moment. We're also seeing that data engineering teams are spending much more of their time higher up in that stack. So they're spending a lot more time enabling users and building out self-service tooling. Just going from the bottom of the stack up to the top. So if we start at the lowest level, which is storage, so actually how you store and organize your data. I think here one of the key themes that we've seen is cloud. So a lot of organizations are leveraging cloud today to store their data. And a lot of organizations are also using more open source database technology or cloud-based database technology. And really what this has enabled organizations to do is spend less time focusing on the nuts and bolts of storages or database administration. I'll also highlight Parquet here. So Parquet is a file format that has really taken off. It's used in lots of different data science platforms. Users really like it, and it underpins a lot of a sort of modern day stack. So the next layer in our data science platform is compute and orchestration. So this is all about how you can process your data across multiple servers and at multiple times of the day. Here, I think Spark has become pretty much the de facto tool that is used that came out of the Hadoop ecosystem. And Spark allows you to scale jobs from a single laptop up to hundreds of thousands of servers in the cloud. Another product here I'll flag is Airflow. So Airflow is a job scheduler. So it enables you to kick off your ETL processes either at specific times or when specific dependencies have been met. It was originally built by Airbnb. It was open sourced. It's now part of the Apache Foundation. And again, it's really bedded itself into the modern data science stack. The next layer up is all about manipulating data. And this is where you can really start extracting value from your data and gaining insights from your data. At the lowest level, there's libraries such as Pandas and NumPy. So we're a Python shop here at Man Investment, so we use Pandas and NumPy really, really heavily. Pandas is mature now. It's got lots and lots of documentation, and actually users across the organization are pretty comfortable using it. So I definitely take a look at Pandas if as a quick way of manipulating data. The final two layers, right at the top of this stack, are much more tailored to the business. And this is now where we're seeing a lot of the focus of data engineering teams. Data analytics and data processing. So a couple of things we might see here are common ETL or data ingestion pipelines, and I'll talk about that a little bit later in this talk. But we may also see custom reporting packages. While a lot of these are much more bespoke to the actual business's need and the business use case, I'd say actually what really enables a lot of these tools is other open source or common commoditized building blocks all combined together. So it is enabling users to really just focus on the task at hand. There's a lot of different packages out there in the open source ecosystem. I think my final takeaway on this slide would be, if you're just starting out on this journey, to provide users with what I call a paved road. So sort of a recommended set of tools and workflows. And if you can provide even a standard stack that could be used across your organization, that's even more powerful. That means that users don't need to understand all of the technical details, and instead they can just start operating and understanding and deriving data without having to understand how data is stored at the lowest level. Bit of a shameless plug here for open source at Man. We leverage a lot of open source internally, and so open source is very important to us, and we feel like we should give back to the open source community. I'll just highlight a couple of projects on this slide. The first one I'll highlight is a product called Notebooker. So Notebooker is a really easy way to enable your teams to have self-service reporting. So if they're comfortable writing an IPython notebook, what we can do is integrate that into the Notebooker server, and it will run the notebook on a schedule. So if you want a notebook generated and emailed to you every day at 8 in the morning, you can just integrate your notebook with Notebooker, and every morning you'll receive an email of the output. The second product I'll highlight is Detail. So Detail gives you an Excel-like interface to data from a Jupyter notebook. It's a really good way of enabling sort of less data savvy users to interact and explore and play and chart with data. And certainly one thing that we found useful is canned notebooks with the data embedded with a detail window. So we've touched on the open source ecosystem, and we've spoken about the commoditization at the bottom of that stack. But I thought I'd give you a little bit of an overview of the sort of areas where we see data engineering teams today focusing their time. With data ingestion, this is really all about getting raw data into your organization, getting it stored, getting it mapped, and getting it in the hands of users. I think here, a key theme we've seen is self-service. And if you can build a really easy to use self-service data platform that takes away a lot of the complexity for users, and if you underpin that with a really strong data engineering function and strong data governance, then you can really increase the velocity of data in your organization. Depending on your use case, there'll be different steps within an ETL pipeline. I'll just highlight a couple. So the first one I'll highlight is storage. Storage, there's lots of different ways to store data. There's possibly different places to store data, and there's different shapes to store data. And one theme that I've certainly witnessed is the more that you can actually standardize on your storage, actually the more velocity and the easier it is for your users to use it downstream. So if your users always receive similar shapes of data, then actually it stops them from having to continue to understand the kind of raw construction of how that data was formed. The second piece in this pipeline that I'll highlight is mapping. So mapping is where we take a raw data file, and that might have an identifier in it, such as a website. It might have www.apple.com, and today they had 2.3 million users. What we need to do is we need to bring in that data, and we need to somehow link that website address to our internal representation of Apple, and we call that mapping. Mapping, again, is something that on the surface seems extremely simple, but actually there's lots of common pitfalls here, and the more that you can standardize mapping, again, particularly within financial data, I think the more velocity you can add to your overall pipeline. I think the other place where we're seeing data engineering teams focus their time is enabling users to perform data analysis. Here it's all about building sort of a democratized data platform, so one that lots of different users with different skill levels can use. And I think the key is not to curtail innovation here. So it needs to be broad, and if you've got say a machine learning team, like a natural language processing project, then if they can hook in at a very low level in something like Spark, that could be really beneficial. On the flip side, if you've got an operations team, they might want to access a much higher level. And so if you can provide this rich ecosystem with different methods to interact with it, that can be very powerful. There's a couple of pieces to this. So the first one's data discovery. I think data catalogs and data discoveries become much more of a first-class concern. And if you can provide a simple way for your data to discover what data is available in the organization and they're entitled to, this can really speed up innovation in the organization. Users don't have to discover it through word of mouth. They can simply go and they can explore, and they can apply a data set that they didn't think would be applicable and find it does. Data access is the second piece. Here, I'd really think about the different users that you have on your platform. So if you have a very technical team, they might want to access your data via an API. If you have less technical users, they might want a CAN notebook or even a report. So enabling users through different services, be that say Notebooker, so the self-service reporting, all the way through to APIs, that can give you real power. The final piece is data analysis. Having lots of different ways to analyze data, I think really does give you an agility and enables innovation. But at the same time, if you can provide that paved road, that can also reduce complexity so that users can just focus purely on the data that they're crunching. And so having simple wrappers to say, in one line of code, launch some data analysis across 3,000 machines, those sort of common utilities can actually be really powerful. So I'll finish on my views on the future of the data engineering. I think firstly, I think we're going to continue to see data engineering growing, and firms are going to continue to invest in data engineering and data science. However, I think the focus of those teams will change, and they'll be much less focused on actually data ingestion and database storage, and they'll be much more focused on enabling users throughout the whole organization to manipulate and analyze data. I think they'll also always focus on some of these harder problems, kind of running 5 years or ahead of the data sets that we have today. So dealing with things like scale and the complexity of data and efficient use of resources. Secondly, I think we'll see this theme around democratization of data. I think data fluency is going to continue to increase across the organization, both through users upskilling, but also through new graduates coming into the firm who just naturally have more technical skills. And that's really going to mean that if you can focus today on building self-service tools, then you can really capitalize on that in 2 or 3 years when more of the workforce is data fluent. Finally, I think the build versus buy mix might change. So today, a lot of those lower levels in the data science stack are commoditized, and actually a lot of the cloud providers can provide you with them at a click of a button. I think we'll continue to see commoditization within those layers. But for an organization of kind of our scale, I still think we're quite a distance away from a full true data platform in the box. And I think we'll always have a large data engineering team focused on building tailored solutions. So in summary, I think data capability is going to continue to be a key competitive edge, both within the asset management industry and beyond. Open source software is going to continue to commoditize those lower layers. And then data engineering teams are going to shift. They're going to move to much more of an empowering and enabling role in organizations as data fluency really increases. That's all from me today. I really hope you enjoyed my talk. If you've got any follow-up questions, I'm more than happy to answer them, so please send them through. And yeah, I hope you enjoy the rest of your conference.